Hi, this is Rakesh Naik. Today we are going to take one more application of divide and conquer, that is quicksort. But before we start, a small information I'd like to share. In this channel we produce every video in 2 different languages. If you want to watch this video in Hindi, kindly follow the link given in the description. And if you have not yet subscribed, please subscribe and press the bell icon so that you will get regular updates from this channel. So, let's start. In our previous videos, we have already seen what is a divide and conquer problem solving technique. In this video, we are going to see what is quicksort, how it works, and how to find its complexity under different situations. Basically, quicksort is developed by Tony Hoare in 1959. Sometimes it is also called as partition exchange algorithm, and it is the quickest or the fastest sorting algorithm known till date. The basic problem statement is, if an array is given A, then we need to sort the elements of an array using divide and conquer method. Quicksort is an in-place algorithm because while sorting we don't need any other additional data structure for intermediate saving. So in-place algorithm updates the input sequence only through replacement or swapping. So let us see what are the steps that we are going to use while implementing quicksort using divide and conquer. The first thing is we'll be dividing. If an array A has at least 2 elements, select the element X as pivot element. Usually we take one at the end of the list and remove all the elements of A and put them into 3 sequences. The first sequence is L. In A less than X. If X is the pivot element, then all the elements which are less than X is one part. E means which is equal to X is one part, and G are all those elements which are greater than the pivot element X. Then we will recursively sort L and G, those elements which are less than the pivot element and those elements which are greater than the pivot element. And the last step is conquer. We will put the element back into the order, first inserting the element which belongs to L, then those elements which are E, and finally those elements which are of G. So the algorithm quicksort has 3 parameters, A, P and R. P is the pivot element, and if P is less than R, then we'll take one more algorithm called partition and we'll find Q. Then we'll apply quicksort algorithm to A, P, Q minus 1, then A, Q plus 1 and R. Then what is this partition algorithm? Let us see. Algorithm partition, A, P and R we are taking. The rth element will save it in the variable X, and I'll take one more variable I which will save P minus 1. I'll take a for loop for j equal to P to R minus 1. If jth element of array A is less than or equal to X, then I'll increment I by 1 and exchange AIth and AJth element. Otherwise, I'll exchange AI plus 1th and ARth element, and I'll return the value I plus 1. Here the variable j that we have taken in the for loop is used to scan the list from left to right, and whenever it finds an element less than the pivot element P, increment the value I and swap AI and AJ, otherwise simply we'll increment the value of j. Let us try to understand this with the help of this example. So this is an array, 0 to 8 are the index and the value given are 8, 5, 4, 0, 7, 2, 3, 1 and 6. Now we are calling our quicksort algorithm, A, P and R. So here P is less than R. We will be calling the partition algorithm with parameter A, 0 and 8. Now after calling partition algorithm, we will be getting this particular data. Here we are going to check A0 and the pivot element. Here A0 value is greater than A0 value is 8 and the pivot value is 6. So 8 is greater than 6. So we are going to increment j by 1. The next is A1 value I am having as 5 and the pivot value I am having 6. So 5 is less than 6. What I am going to do? I am going to increment I by 1 and exchange A0 and A1 value and then increment j by 1. So I is incremented by 1. I have exchanged these two values and j is incremented by 1. Now aj value is pointing to 4 and a pivot value is pointing to 6. 4 is less than 6. The same thing we are going to do. We are going to increment I by 1 and we are going to exchange A1 value and A2 value. So I is incremented by 1 and these two values 4 and 8 got exchanged and j is now incremented by 1. Now A3 value is 0 and a pivot value is 6. 0 is less than 6. The same thing we are going to do. I we are going to increment by 1 and we are going to exchange A2 and A3 value. Then we will increment j by 1. So here you can see if I is incremented, it is pointing to 8 and after swapping 0 came to this side. Now j is incremented by 1. Now A4 value is 7 and a pivot value is 6. What we are going to do? We are going to simply increment j by 1. So j is now pointing to 5th index. Now at the 5th index the value is 2 and the pivot index the value is 6. 2 is less than 6. So what we are going to do? We are going to increment I by 1, exchange A3 and A5, then increment j by 1. So I is incremented and 2 and 8 got exchanged. Now j is incremented by 1. Now j value is 3 and a pivot value is 6. The same thing we are going to do. I will be incrementing by 1 and we are going to exchange 3 and 7. And j is going to increment by 1. Now A7 value is 1, a pivot value is 6. The same steps we are going to do. I we are going to increment and 8 and 1 we are going to interchange. So 1 came here and 8 is now. And now the loop came to r minus 1. So what we are going to do? We are going to increment I by 1. We are going to exchange the pivot element and a6th element. The pivot element 6 came here and 8th location the value came to be 7. Now you can see here this value 6 is fixed. Now you can see here at location 6 the value is 6. Towards its left whatever data I am having all of them are less than 6 and whatever data after 6 which are greater than 6. So this part I will say L, this is my E and this is G. So all the elements which are less than 6 are on the left side of this index and the value which are greater than 6 are to the right of this particular value. Now again we can call algorithm quicksort 0 to 5. So 0 is the 0th index and 5 is the pivot value. 6th index is already in place. So I need to apply the quicksort algorithm for this data as well as for this data. So if I want to see the flow from 0 to 5, if I want to apply quicksort, value 1 will be in place. Again, I need to apply for 0. Only one single data, that's why it is in place. Then I have to apply 2 to 5. For 2 to 5, I will find 4 will be in place. On this, again I have to take the left hand side and right hand side. I will find 2 is in place and then 3 is in place and then I will take single data 5. It will be in place. Next I will take the right hand side data and I will find the 7th data will be in place and then 8th data will be in place. So this is how the control will be shifted from one part to other part and without using any temporary location we have sorted the data. So how basically the flow is controlled? Whenever we called quicksort A, 0 and 8, we called 3 function. One is partition, then 2 quicksorts. So the data I got is 6. So 0 to 5 one data and 7 to 8 one more data. Value 6 is in its place. Then I'll call 0 to 5. If I'll call 0 to 5, number 1 is in place. So 0 to 0 and 2 to 5. Again I need to call. So single data is always sorted. So I'll call 0 to 5. If I call 0 to 5, the partition value will be 4. So my data that I need to sort is 2 to 3 and 5 to 5. 5 to 5 is single data, so I need not do anything. For 2 to 3, if I'll sort, I'll find the partition to be 2. So 2 to 2 and then 3 to 3. Again, the right hand part I need to see, 7 to 8. 7th I find is the partition, so 7 to 7 and 8 to 8. So this is how the control is shifted. So this is the first work I did, then second and third work, then fourth, fifth and sixth. As this is a single data, so the sixth work is this one, and on this 7 and 8 I have to do, because this is a single data, so I need not sort. For 8 again I have to do 9, 10 and 11 work, and then I will be getting 14, 15 and 16. So this is how the operation will be performed while sorting the data. Now let us see the time complexity. We can observe that the algorithm A, P and R is called the array and divided into two parts. All the elements which are less than the pivot element are to the left of it, and all the elements which are more than the pivot elements are to the right side of it. So in the best case, what we need to do whenever we are dividing the left side and right side, it will be having exactly n by 2 elements. So the height of the tree will be log base to n. It means we are having n data, then left hand side n by 2, right hand side n by 2. Again this n by 2 will be having on the left hand side n by 4, right hand side n by 4. Again for this also left hand side n by 4, right hand side n by 4. And the height of the tree, if n equal to 8, then the height of the tree will be 3. So we can see the height of the tree we can get by log base to n. Let us see the time complexity in worst case. So after finding the pivot element, I am dividing. Some element will be less than the pivot element, some element will be greater than the pivot element. Let us assume that there are n minus 1 number of elements which are on the left hand side and one element is there on the right hand side. So looking like this. So if I am dividing n minus 1 element on the left hand side, one element on the right, again n minus 1 element on the left hand side, one element on the right, again n minus 1 element on the left hand side, it means the height of the tree might be as big as n, because every time one element is kept on the left hand side. Assume that we are taking quicksort of APR, time is Tn. So the time requirement for partition is big O of n. In the best case, the pivot element is in the middle, so we get equal size partition. So let the quicksort be quicksort of A, P, Q minus 1 and quicksort of A, Q plus 1 and R, and each of will take n by 2 times. So the recurrence relation is Tn equal to 2 T of n by 2 plus big O of n. So the complexity is theta of n log base to n. And in the worst case, the time required for partition is big O of n. It may happen that on the left hand side the pivot element we have 0 element and we have n minus 1 element on the right hand side. So the recursive relation will be Tn equal to Tn minus 1 plus big O of n. So if you want to solve it, it will be big O of n square. I hope you understood what is quicksort and how to find complexity of quicksort. If you understood, give me a like and share among your friends. In our next video, we are going to talk about one more